Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.1 from the book Applied Thermodynamics by McConkey. So, the statement of the problem is a mixture of carbon monoxide and oxygen is to be prepared in the proportion of 7 kg to 4 kg in a vessel of 0.3 cubic meter capacity. So, first I write the given data in which in the proportion of in the mixture of carbon monoxide and oxygen, the mass of carbon monoxide is 7 kilograms. So in given data, mass of CO2 is equal to 7 kg and mass of oxygen is equal to 4 kg and volume of the vessel. So volume of the vessel is 0.3 cubic meter. So it means that V1 is equal to V2 is equal to V is equal to 0.3 cubic meter. If the temperature of the mixture is 15 degrees centigrade, initially temperature is 15 degrees centigrade, and as we will use the ideal gas equation, so convert degree centigrade into Kelvin. So 15 degree centigrade is equal to 15 plus 273 Kelvin, which is equal to 288 Kelvin, and determine the pressure to which the vessel is subject. It means that determine the initial pressure at this temperature. Now if the temperature is rise to 40 degrees centigrade, now final temperature is 40 degrees centigrade. Convert this into Kelvin. So 40 plus 273 Kelvin, which is equal to 313 Kelvin. Required is find pressure at temperature T1, which is basically P1, and find pressure at temperature T2, which is equal to P2. So find P1 and P2. So initially we are finding number of moles of carbon monoxide and number of mole of oxygen. So in solution, we know that formula per number of moles is equal to mass divided by molar mass. Mass of carbon monoxide and oxygen is given to us, and molar mass per carbon monoxide is denoted by m dash. Molar mass per carbon monoxide is equal to, this is basically carbon monoxide. Carbon monoxide is per carbon is 12 and oxygen 32. So 32, oxygen is 16. So 16 plus 12 is equal to 28 kilogram per kilomole, and molar mass of oxygen is equal to 32 kilogram per kilomole. So number of moles of carbon monoxide according to this formula. So mass of carbon monoxide is given to us is 7 kilogram, and molar mass of carbon monoxide is 28 kilogram per kilomole. This kilogram will be cancelled with kilogram. So number of mole of CO is equal to 7 divided by 28 is equal to 0.25. This is kilomole. Now number of mole of oxygen is equal to mass. Mass is given to us as 4 kg, and molar mass of oxygen is 32 kilogram per kilomole. Kilogram will be cancelled with kilogram. So number of mole of oxygen is equal to 0.125 kilomole. Now to find pressure P1 at temperature T1, we have the equation as P1 V1 is equal to nRT1. So P1 is equal to nRT1 T1 divided by V1. Now N is basically equal to number of mole of CO plus number of mole of O2, which is equal to 0.25 plus 0.125 kilomoles, which is equal to 0.375 kilomoles. So N is equal to 0.375 kilomoles. R is universal constant. So universal constant, this is equal to 8.314 kilojoule per kilomole per Kelvin, and T1 is equal to 288 Kelvin, which is given. V1 is equal to 0.3 cubic meter volume of vessel. V1 is equal to V2 is equal to V. So multiply these values, 0.375 multiplied by 8.314 multiplied by 288 and divide by 0.3, which is equal to 29 point, which is equal to 2 2993.04 and calculate the unit. So kilomole will be cancelled with kilomole, this Kelvin will be cancelled with Kelvin, and this will be equal to kilojoule per cubic meter. So kilojoule is equal to Newton meter divided by cubic meter. So we can write cubic meter as meter into square meter. So meter will be cancelled with meter. So kilonewton per square meter is equal to kilopascal. Newton per square meter is basically kilopascal. To convert kilopascal into bar, divide by 100, because 1 bar is equal to 100 kilopascal. 2993.04 divided by 100. Now kilopascal will be bar. So P1 is equal to 29.93 bar. Now to find P2 at temperature T2, use the above formula again for P2. P2 V2 is equal to nRT2, and this is V2. N is equal to 0.375 kilomole. R is universal gas constant, which is equal to 8.314 kilo. This is basically R dash. Kilojoule per kilomole into Kelvin, and T2 is 313 Kelvin, which is given to us, and V2 is 0.3 cubic meter. Now multiply these values and divide by 0.3, which is equal to 3252.85, and calculate the unit. This kilomole will be cancelled with kilomole, Kelvin will be cancelled with Kelvin, so this unit will be kilojoule. Joule is equal to Newton meter, and meter cube is equal to meter into square meter. So meter will be cancelled with meter. So this is kilonewton per square meter, which is equal to kilopascal. And to convert kilopascal into bar, divide by 100, which is equal to 3252.85 divided by 100 bar. So P2 is equal to 32.5285 bar, and this is the final answer, and this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.